In this video, we're going to calculate different measurements of motion. So speed, velocity, acceleration. I'm going to show you how to solve the following two problems, and then you should be able to try some on your own. If you remember, the equations for speed, velocity, and acceleration are as follows. Speed is simply distance divided by time. You know that fraction bar means division. Velocity is speed with direction. So the formula is the same as speed, and then we simply add the direction in our answer. And acceleration is a change in velocity, so there's a little bit more information. So we need to know the velocity that we ended with, the final velocity, the velocity that we started with, which initial means what you start with. And again, it's divided by time. So you may see this shortened as VF minus VI or V0 divided by time. Let's take a look. A girl travels 20 miles on her bicycle. The trip takes 2 hours. Express her speed in miles per hour. So the variables we have are how far she went. Her distance was 20 miles. The time it took her was 2 hours. So T for time, 2 hours. The equation, speed equals distance divided by time. And that means we will do 20 divided by 2. 20 divided by 2 equals 10. And since we have miles divided by hours, we simply write that as a little fraction, 10 miles per hour. We don't have a specific direction that the girl was traveling, so we just have the speed. Next, a car starts from a stoplight and is traveling with a velocity of 10 meters per second east in 20 seconds. What is the acceleration of the car? So I know the car started from a stoplight, and if a car is stopped, its velocity is 0. It is not moving. This is our initial velocity because that's where we started. And then eventually it gets up to 10 meters per second. So that's our final velocity that we're considering here. And that would be east. We can add that on at the end, okay? And our time, 20 seconds. The equation for acceleration, VF minus VI divided by time. So if I replace or substitute the values in, VF is 10, VI is 0, and time is 20. I'm going to solve 10 minus 0 first, which is 10. Time is still 20, and 10 divided by 20 is 0.5. Now, the 10 is meters per second. The 20 is seconds. And if you remember, that simplifies to meters per second squared. To the east. If you'd like to follow along and learn how to do one more type of example where we give you the speed and you have to find one of the other variables, continue watching, or you can stop here and go try the practice problems on your own or with a partner. Lastly, if you decided to keep watching, how far in meters will you travel in 3 minutes running at a rate, and another word for rate is speed, of 6 meters per second? So we know the speed is 6 meters per second. We know the time is 3 minutes. And the distance we do not know. So this one has a little bit of an extra step. As you can see, the speed mentions seconds, but we're talking about 3 minutes of time. So let's actually do that conversion right now. 3 minutes, and there's 60 seconds per minute. So 3 times 60 means 180 seconds. The equation is the equation for speed. So speed equals distance over time. And the calculation, well, it would look like 6 equals d, we don't know d yet, that's what we'll find, divided by time, 180 seconds. So in 180 seconds, how many meters can we run? In order to solve this, we would use the inverse operation. Let your math teachers know. Hopefully they will be proud. We would multiply, instead of dividing by 180, we would multiply by 180 on both sides. 180 times 6 is 1,080. So we would be able to run 1,080 meters in 180 seconds, or 3 minutes.